Welcome to Stay Freeze Academic Tuition Center. I want us to do chemistry and more concept calculations. So as you can see, the first part here, determining the number of atoms in a compound, which means finding the number of atoms in a given compound. So I have the first question here, which is an example. The question reads, question 1, what is the total number of atoms present in a molecule of this is lead 2 nitrate? So the formula for the lead 2 nitrate is given, as you can see. It's supposed to be a comma here. It's given. So it is a PB and nitrogen, oxygen 3 bracket and 2 here. So they want us to find the number of atoms present in this molecule. So what we need to do, we'll count element by element. So start with the oxygen. So as you can see here, we have 3 oxygen here. So this 3 is only on oxygen here. So 3 multiply by, so don't forget we multiply here. So multiply by these 2, as you can see we have 2 here. Then equal to 3 times 2, the answer is 6. Then again go to nitrogen. As you can see here, nitrogen, there's 1 here. Since there's no number, it means there's 1. So 1 multiplied by the 2, which is outside the bracket. So 2 equal to 2. Then we go to lead. Again, do lead. Okay, lead. This is as you can see, there's 1 here. So I'm going to say 1 multiplied by. So don't forget there's 1 here. So multiply by 1. The answer is 1. So then we add. So the 6 plus 2 plus 1. The answer is what?
9.
9. So 9 atoms. That's the final answer for this question. Then go to question B. Sorry, question 2. Question 2 again reads, find the total number of atoms in ammonium phosphate. So they want us to find the total number of atoms in this compound. So we'll start. Don't forget, see there's no number here, to me there's 1. There's 1 here, so we put a 1 here. So we'll start with this one. So as you can see, we have 4 atoms of oxygen. So we say 4 multiplied by this one in front here. The answer is equal to 4. Then again, phosphorus here, we have got 1 here. 1 multiplied by the 1 in front here, which is 1. The answer is equal to 1. Then again, hydrogen, we say, don't forget here, this 3 multiplies everything inside the bracket. So this 4 multiplied by the 3 there, then multiplied by 1, this one here, then equal to 12. Then nitrogen again here, we have this 1 in front here, multiplied by the 1 here. Then again multiplied by this 3. So it is times 3, then equal to 3. 3 here. Then we add everything. So 4 plus 1 plus 12 plus 3, what's the answer?
20.
20 atoms. That's the final answer there. Good. Question 3 reads, find the total number of atoms in 3 moles of ammonium sulfate. So this is a formula for ammonium sulfate. So they want us to find the total number of atoms. So they were going to do it like this. As you can see here, we have this 4 multiplied by the 3 in front here, equal to 12 here. You go to this one, hydrogen. Hydrogen, as you can see, we have 4 here, which is 4 multiplied by the 2 here, multiplied by the 3 in front here, equal to. So the answer here, 4 times 2, which is 8. 8 times 3, 24. Then in fact I've forgotten 1 here, which is sulfur here. So I'll do though this is wrong, it's unprofessional, so I'll just do it from here. So for here of 1 multiplied by the 3 in front here, so to give me 3. Then nitrogen, there's 1 here, 1 times the 2 in outside the bracket, then times the 3 in front, equal to 6. Then I'll add everything. So now add 12 plus 24 plus 3 plus 6. The answer is 45
45.
atoms. The final answer. Good. Then now question 4 reads, how many different atoms are in sodium ethanoate? So here we need to be very careful. They didn't tell us to find or calculate the number of atoms, but how many different atoms are here? So in this case, we have sodium here, also have oxygen. So this oxygen, since it's the same as this one, so it's repeating, so we're going to ignore it. So we're going to also have carbon here, also have hydrogen here. This is carbon as well. Since carbon is already repeated here, so which means we're going to ignore it. So the different atoms here, we have 1, 2, 3, 4. So we have 4 different atoms. So this is the final answer, 4 different atoms.
So the next question or the next topic that we'll be covering is relative molecular mass, which is also known as MR. And then to find the relative molecular mass, here we have questions, and the first one reads, find the relative molecular mass MR of the following. A. Hydrogen chloride, which is in symbols HC and a small l. So here we'll say A, HCl. Then chlorine has a mass number of 35.5, and that's what we're going to get here. So just to explain more, the mass number is the one that is always at the top, and then the proton number is the one at the bottom. Mass number can also be called atomic mass or nucleon number. And then here I already showed that the mass number of chlorine is 35.5, so that's what we're going to put here. 35.5 times 1, there's only one chlorine atom, is equal to 35.5. And then hydrogen's mass number is 1, the one at the top here, so that's what we're going to put here. So 1 by 1 hydrogen atom is equal to 1. And 35.5 plus 1 is 36.5. So that's our MR for hydrogen chloride, sorry. And then the next one, B. And here it's carbon dioxide, which is CO and a small 2 at the bottom here. So I'm going to put it here. And then the mass number for oxygen, which is always at the top, is 16. So that's what I'm going to put here. And since there are 2 oxygen atoms, I'm going to say multiplied by 2, which is going to give us 32. Then here, carbon is 12. So we're going to say 12 by, there's only one carbon atom, so we're going to say multiplied by 1 is equal to 12. And 32 plus 12 is 44. So that's the relative molecular mass. So here it is. Then C, which is sodium sulfate, represented by N small a 2 at the bottom, SO and a small 4 at the bottom here. So I'm going to just write it here. It is Na2SO 4. So here the mass number of oxygen is 16. So that's what we're going to write here. Then since there are 4 atoms, we're going to say by 4 is equal to 64. And then for sulfur, the mass number is 32, so that's what we're going to write here. So 32 by 1 sulfur atom is equal to 32. Then here for sodium has a mass number of 23, so that's what we're going to write here. So 23 by 2 sodium atoms here at the bottom is equal to 46. So 64 plus 32 plus 46 is equal to 142. And that's the relative molecular mass for sodium sulfate. Then the next one, which is copper in brackets 2 sulfate to 5 water. So this is called hydrated copper 2 sulfate. It is hydrated because of the 5 molecules of water, and then copper 2, the 2 here, that's here, and also the valency for sulfate, which is 2, they cancel each other. Even though it's not there, it's still copper 2 sulfate. Yeah. So I'm going to write it down here. So first we have oxygen. So the mass number for oxygen is 16, as we already said. So 16 by here, this 5 is going to be multiplied by all of the atoms in the molecule. So 5 by 16 is equal to 80. And then we have hydrogen here, which has a mass number of 1 here. And we're going to say, since the 5 again is multiplied by the whole molecule, all of the atoms in the molecule, we're going to say 5 by 2 hydrogen atoms. So by 2 by the mass number, which is 1. And that's going to give us 10. And then here we have oxygen again. And as I already mentioned here, oxygen has a mass number of 16. So it's going to be 16 by 4 oxygen atoms. So by 4 is equal to 64. Then here, sulfur, has a mass number of 32. So we're going to say 32 by, there's always a 1 here, so I'm going to indicate it there. So 1 by 32, which will give us 32. And then here copper, which has a mass number of 64, and multiplied by 1, it's going to be 64 by 1 is equal to 64. So 80 plus 10 plus 64 plus 32 plus 64 again will give us 250, and that's the relative molecular mass for hydrated copper 2 sulfate. Yeah. So next we have this one, which says 3 moles of ammonium carbonate, which is here represented in its chemical formula. and we're going to write it down here. So 3 moles of ammonium, which is HO2 carbonate, and here we're going to say the mass number of oxygen. The mass number of oxygen is 16, so 16 by 3 atoms here, which is going to give us, sorry, I forgot to include that this 3 is going to be multiplied by the whole equation. So we're going to write by 3 here, which is going to give us so 16 by 3 is going to give us 144. So that's what we're going to write here. Then for carbon, the mass number is 12. So 12 by the 3, which will be multiplied by all of the atoms, is going to give us 36. Then here, hydrogen, which has a mass number of 1, multiplied by the 4 here, and the 2, which has to be multiplied by the nitrogen as well. So 1 by 4 by 2 by the 3 as well. It's going to give us 24. And then for nitrogen, the mass number is 14 by this 3 is going to give us 14 by 3, which is 42. So 42 plus 24 plus 36 plus 144 is equal to 246. And that's the relative molecular mass. So sorry guys, I forgot that the 2 is also going to multiply, is going to be